Hello everybody. Today we are going to do this foundation paper chemistry AQA 2025 and I take free classes on Teams. I teach math and science. Um, so if you want to join me, you can comment. I can give you link or I can give you here my WhatsApp number. You can text me here 9205948909. This is my WhatsApp number. I to get the link you can uh, text me here. Okay, let's start with first question. So this question is about elements and compounds. What is the name of the compound with formula ZnBr2? Use periodic table. So this is consist of Zn means it is zinc and Br2 is bromine. This Br is bromine if you check from the periodic table. So when we this is compound, first element keeps its name as it is, and second elements take this suffix ide. So this will become zinc bromide. Okay, so the correct option is zinc bromide. And then next is a compound has this formula C2H6O. Show table 1 is showing some information about this molecule. Symbol is given, number name of element. So C is this symbol, it means carbon. This is carbon element, and you can see there are two atoms, right? Because this two, tiny two, this means number of atoms are two in carbon. Next is H. H is hydrogen. How many atoms are there? You can see this tiny six, so there are six atoms. Then this oxygen symbol is O. You can even check from the formula O, and there is one atom, so there is no number. If element is written like this, like oxygen, it means it is one. We don't put one here, but it means one. Okay. Let's see the next question. The next question says potassium and sulfur react to produce potassium sulfide. Write the word equation for this reaction. Okay. So potassium, it says word equation. Okay. So we don't need to write symbols. So this side we write reactants, the things that combine to give us the result. This is called product. So what are reacting? Potassium. So we'll write here potassium first. What it is reacting with? Sulfur. So we'll write here sulfur, and it produce what? Potassium sulfide. So potassium sulfide we can write here, and that's it. So this arrow is showing that this is the substance produced, and the substance we start with are called reactants. So these are reactants and this is product. You should know this. And this arrow means they are producing this. This plus means they both are reacting. Okay. Next is aluminium reacts with fluorine to produce aluminium fluoride. Balance the equation for this reaction. So aluminium symbol is Al, and then fluorine symbol is F, and it is giving aluminium fluoride. The reaction is given, we have to balance. Okay. Balancing means you need to ensure the number of atoms for each element is same on both side of the arrow. Okay, this side and this side, reactant and product side. So as you can see, aluminum, first we'll identify the atoms. We have aluminum, fluorine. Then we'll count. So I will write aluminum and fluorine. Then we will write here uh, left side and right side. Okay, so how many aluminums are there? Left side one, this side we have two. You can see this two in front of aluminum, that means two. Fluorine we have two, and this side, how do we count this fluorine? This two will multiply with this tiny three, so 2 times 3 6. That means right side we have 6 fluorine. So what we can do, if I multiply this with 2, I will make it 2, right? So this left side I will put a 2. So now we have balanced aluminum, right? Now, if you check fluorine, what I can do, how can I get 6? If I have 2, I can multiply it with 3. 3 times 2, 6. So I can put here 3. Now you can see 3 times 2, 6 fluorine, 3 times 2, 6. So it is balanced because the number of atoms each side is same. Okay, next question is this. Metal reacts with acid to produce a salt and a gas. Which salt is produced when magnesium react with hydrochloric acid? So it will, because magnesium is reacting with hydrochloric acid, so it will produce magnesium chloride because it has chloric acid, right? There is no nitrate, so this is not possible. There is no sulfate, so this is not. So correct option is first. Which gas is produced when magnesium react with hydrochloric acid? So the gas which produces hydrogen. Okay. So because whenever a metal like magnesium react with acid, it undergo a displacement reaction, and it will produce hydrogen because here we have hydrogen, right? Okay. Next is this. We have given an experiment steps, I think. Yeah, let's read. A student investigated the temperature change um, in the reaction between metal and hydrochloric acid. And this is the method he used. He measured 25 centimeter cube of hydrochloric acid at this temperature into a container. He add 1 gram of metal, record temperature change, repeat steps 1 to 3 using a different metal. Draw one line from the type of variable and the name of variable. So independent variable means this is the variable that student actively changes in step 4. It is um, independent is like here you can see repeat steps 1 to 3 using a different metal. So type of metal is independent. And dependent variable is temperature change. Because this is the variable being measured as a result of changing this step 3 step, record the temperature change, right? So and you can see the what is the constant? Mass is constant, right? Mass is constant and volume of hydrochloric is constant. So what is dependent and independent variable? Just to give you more idea, dependent is like factor you change on purpose to see what happens. Okay. That's independent, sorry. And dependent is the factor you measure to get your result. Okay. So temperature change is dependent, and independent is the factor that you change on purpose to see what happens. Now let's see the next one. It says which container could be the most suitable to reduce energy transfer with the surrounding. So it can be this polystyrene cup. Why? Because of insulation. Polystyrene is a very poor conductor of heat. Okay, poor conductor of heat, and it contains many small packet of trapped air. And since air is an excellent insulator, so it will reduce the rate of conduction. And the other options are copper is a very good conductor of heat, so it can't be. Glass is better insulator than copper, but it is more much more conductive than polystyrene, so this is the better. Okay, let's see the next question. There is a figure which is showing the part of the scale of thermometer used in the investigation. What is the resolution of the thermometer? So how do we find resolution? First, we identify the interval. So if you see these small division between um, like these, first you have to find the value of smallest division on the scale. So there are markings for every 20 units. 20, 20, it is increasing by 20, right? So basically, as you go like 20 to 40, so intervals are 20, right? Then you count the division, like between these two, how many divisions are there? There are total, if you see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10, right? So what is the formula for resolution? I will write it here. For resolution, the formula is difference between major marks divided by number of division. So difference between measure marks, suppose you take 60 and 40, or just subtract them, you will get 20, right? Difference means you need to subtract them. Number of division, how many small divisions are there? 10. So if you divide them, you will get 10. Okay. Sorry, 2. 20, this is 2 degrees Celsius. So the correct option is this. The smallest change the thermometer can show is 2. Next question is this. The reaction between a metal and an acid is exothermic. What happens to temperature of the mixing during the reaction? Take one box. So because it is exothermic, exothermic means what? Exothermic reaction is one that release energy. Okay, it releases energy into the surrounding and in the form of heat, or usually it is in the form of heat. So what will happen? The chemical energy of the reactant is converting into heat, right? So this heat released into the solution and which will increase the temperature, right? Because the heat is released into the solution, so it will increase the temperature. Okay, next question. Okay, so figure 2 is showing um, the reaction between a metal and an acid. Okay, so based on this, there are, this is A, B, C, D. So which letter in figure represent the reactant? Okay, so basically reactant means the substance which are mixed to get some product. Okay, so A, this A mark the energy level of starting material before the reaction begins. Okay, so reactants means before the things we are mixing, suppose like A plus B is giving us C plus D, so A and B are reactants here. Okay, but in this one, A is showing the energy of the reactants, so it is A. Which letter represent the activation energy? Okay, so activation as is the energy required to reach the peak of the curve from energy level of the reactant. Okay, so activation means minimum energy needed for the reaction to occur. So activation energy is represented by this C. This this is activation energy. C is the energy required to reach the peak of the curve, right? So this is activation. Next is which letter represent overall energy change? So if you see here, B is the overall difference in energy between reactant, which is A, and product, which is D. Since the product are at the lower energy rate, you can see product are lower than A, than reactant. So this is exothermic. Exo means the energy is released. So B is overall energy change. So this is B. Okay. That means D represent, if they ask you product, D is the product and E represent the total energy of the transition state from the baseline. Okay. So this is a very important concept related to the energy and progress of reaction. Okay. So I can just tell you, even let me just erase it to, so that it does not look messy. Let me change the color. Hmm. So always remember that this side, the horizontal line at the start of the reaction, on the left side, it represent energy level of starting material, which is called reactants, and this letter C, it shows the activation energy, which is the minimum energy needed for a reaction to occur, and it is measured from the energy level of the reactant from here to the peak of the curve. So this, you can see this dotted line, this is showing this is activation energy. And then this B is showing the overall energy change, which is the difference between reactant, because A is reactant and D is product. So you can see this is the difference between these two, right? Change between this and this. So this is overall energy change. This is very important. You should know this. Okay. Okay. So, so yeah, this is there is a cell contained chemical that react to produce electricity. Okay. So basically, a student investigated the voltage produced by four different cells. Okay, and you can see this is the method used to measure the voltage produced by the cell using metal A, B, and then repeat using different metals, and these are the voltage given in volts. Okay, so basically, it is asking which substance could be used as an electrolyte in the cell in figure 3. Okay, I need to see. Okay, so in figure 3, let's go up. This is the figure 3, right? It's asking which substance can be used as an electrolyte. um, the options are pure water, sodium chloride, and potassium bromide. So basically, the sodium chloride solution is the correct option, because an electrolyte must contain free moving ions to conduct electricity, right? And pure water can never be the correct option because it is a poor conductor. Pure means there are no ions, like distilled water. It is made like which we use in labs and all. And sodium potassium bromide cannot conduct, because its ions are locked and they are fixed in its lattice. So the correct option is this one. Which metal A, B, C, or D has was copper? um, Give one reason for your answer. So because copper is often the metal that produce a positive but low voltage, so when it is paired with more reactive metal like zinc or magnesium, um, then um, it produce low voltage. Okay, so which one is producing low voltage, like out of this? um, because copper is produce positive but low voltage, so all of them are positive, but B is showing 0, so low voltage is 0.8. So the answer could be C. Okay, and the reason you will write metal that it produce positive but low voltage when paired with more reactive metal like zinc or magnesium. Here it is paired with okay, copper electrode. Okay, and then it is asking which of these metal, A, B, C, and D in the correct order of reactivity. So higher the voltage produced when paired with a standard electrode like copper, the more reactive the metal is. So you can see the highest voltage is D, right? So this is more reactive. So D is more in reactive. Then second one is A. Then third one is C, and B is the least reactive. Okay. So least reactive, the metal that produce lowest or negative voltage. So this is most reactive is, as I mentioned here, D, then A, then C, and then B. Okay, next one. Next question is, a battery consists of several cells connected together in series. Each cell has voltage this. Calculate number of cells needed to make a battery of voltage this. So total voltage, basically there is a formula which you can apply here. Number of cells is equal to total voltage divided by voltage of each cell. Voltage of each cell. Total voltage are 14.4, right? Volt. And voltage of each cell is 3.6. If you divide it, you'll get 4 volt. Sorry, not 4 volt, 4 cells. Okay, number of cells are 4. So 4 cells are required. Okay, next question. It says, fuel cells can be used to power electric cars. Complete sentence. Choose. Okay. So these options are given. Overall reaction in a hydrogen fuel cell involve the oxidation of hydrogen to produce what? Um, to produce water. Okay, this is the correct option because hydrogen gas react with oxygen from the air, and when hydrogen is oxidized at the anode, overall chemical reaction combines, and hydrogen and oxygen they produce water and also electricity and heat. But out of these option, water is correct. Then rechargeable cells can be recharged when an external electrical current is supplied. When an external electrical current is supplied to a rechargeable cell, the chemical reaction is reversed. Okay, it is reversed. Why? Because these cells contain chemical reactions um, that are reversible. So when you use the battery, chemical energy is converted into electrical energy. And when you plug it in, the external electrical current drives the chemical reaction in the opposite direction, and that's how it works. Okay. Next question is this. So it's represent. Okay, yeah. A student did an experiment to find volume of an acid that neutralized this much of alkali, and these are the method used. So it says, what is the name of this experiment? So the name of this experiment is actually titration, because titration is a method used to determine the concentration of known reactant by reacting it with volume of another reactant, and you can see it is used to find volume, right? And then next is substance X is used in step 2. What type of substance X is? So substance X, it says add a few drops of substance X to the alkali. And here it says that acid that neutralize this much of alkali. So it is substance X is an indicator. Indicator means like it can be methyl orange. It is added in step 2 to provide a visible color change at the end point, which signal that neutralization is taking place. Okay, so this is, we can write, it is an indicator. Okay, okay. Next is, what piece of equipment is used to add the acid to alkali in step 4? What okay, so what is used to add acid? Oh, why it is not moving? Oh, finally. God, just one minute, let me fix it. Yeah, here we go. So step 4, it says add the acid to the alkali until a color change is seen. So what is used? It is called burette. Okay. Here you can see this option is correct. It is used in titration to add acid to alkali in a controlled manner. Okay, like drop wise. Okay. Next, it says suggest one improvement. Um, okay, for this method. So what we can do here, let me see. Okay, step 4, add acid to alkali until a color change is seen. So we can add acid dropwise near the endpoint, right? Dropwise means like drop by drop. When the indicator is about to change, ensure the exact volume. So we can write add acid dropwise. Okay, let me just go with this one. Okay. Next question, there is a table shown and which is showing you was volume of acid in trial 1, 2, 3, and 4. Calculate mean volume of acid needed to neutralize this much. Give your answer to three significant figures. Okay. So The formula for mean is we just add all the values. Okay, just add all of them, like 8.95 plus 9 plus 8.85 plus 8.45, and divided by how many trials are there, 1 2 3 4. So we divided by 4. Calculate me, needed to neutralize. So okay, and trial 4 is 8 point. Do not include the, okay, anomalous result. Okay, okay. So because trial 1, 2, 3, they are within 0.15 centimeter cube of each other, right? 8.45 is lower than other, so that's why it is called anomalous result. So we cannot include it. Okay, just include these two so that we get correct average. Okay, so we can just exclude this. Let me just erase this. mm, it's not erasing, I don't know why. 1 minute. Okay, just forget about it that we have this. We can just erase, go back. Yeah. Now, how many data points we have? One, two, three. So we divide it by 3. If we take 4 points, then we'll divide it by 4. Okay. But it says this, we have to focus in. Okay. Now, if we add, we'll get 26.80 divided by 3, and which is going to give you 8.93333. And because it says give your answer to 3 significant figures, so 3 significant means we need 3 figures only. The answer is going to be 8.93 centimeter cube. Okay. Next question is aqueous solution of acid and alkalis contain ions. Draw one line from each type of aqueous solution to the ion that is always in the aqueous solution. So type of aqueous solution is given, ions are given. We have to match. Okay. So acids, they have H plus ions. Okay. So we'll match it with this. And alkali, they have hydroxide ion. So acids have hydrogen ion, and hydroxide means OH minus ions. Okay. They are even acids are defined by their ability to release hydrogen ions when dissolved in water, and similarly alkaline are defined by the presence of hydroxide ions in their aqueous solution. So you have to remember this: acid H plus ions, alkali OH minus, hydroxide. Okay, the next one is this. Okay, so let me just zoom it so that, yeah. So this question is about electrolysis, and table 4 is showing some of the product of electrolysis of two molten compounds, and we have to complete the table. So molten compound is copper chloride, product at the negative electrode. So basically the copper chloride, and product at positive electrode we are getting chlorine, right? So here we already wrote chlorine, so what is left? Copper, so we can just write copper here because this is the compound, these are two product. Potassium bromide, you can see potassium is already written there. What is left? Bromide. So because this is compound, right, so here we have to write the name of electrode. So this is going to be bromine. That's how you can figure it out, like one of them is written, so other one is going to be this. But don't write like here you can see it's chlorine, not chloride. So similarly bromide is bromine because this one is compound. And then it says aluminum is extracted by electrolysis of molten mixture of aluminum oxide. The product are molten aluminum and oxygen gas. What is the formula of oxygen gas? So oxygen gas that we inhale is O2. When we write O, that's oxygen element. Okay. So this is two oxygen element. And we don't write like this. That's wrong way. So oxygen gas is like this. Okay. Okay. Next is aluminum oxide contains these ions. What explain why aluminum is produced at the negative electrode? Okay. Aluminum at the negative. Okay. So aluminum is produced at negative because aluminum ions, this ion, they are positively charged. You can see there is a positive charge. Let me zoom it. There is this 3 plus, right? Positive charge. And we know opposite charges attract each other, right? They attract each other. So that's why they are attracted to negative electrode because opposite charges attract. And at this electrode, the ions gains electron to form aluminum atoms. So you have to write, um, because it is 2 marks, so you have to explain why aluminum is produced, because they, um, you will write Al3 plus are positively charged and they are attracted to negative electrode because opposite charges attract. Okay. Next is melting point of aluminum oxide is this. Melting point of the mixture is this. Why electrolysis use mixture instead of pure aluminum oxide? Why it uses, because electrolysis, basically to lower the melting point. Like pure aluminum oxide, they have very high melting point. Okay, very high. You can see 2045, and but mixture melts at much lower temperature. You can see 950. So to save energy and cost, we lower the, we use the mixture, and also to increase conductivity. Um, so you can, I'll just write the main point. To lower melting point, second is to save energy and cost, because now we can, you know, it's even half, even less than half, um, when we are using mixture, right, rather than pure aluminum oxide. Third one is to increase conductivity. You can write any 2 points and explain them as I explained already. So if you want to write, you can pause my video and um, understand what I'm saying and then write the answer. This will also help you to, actively participate here in solving. The positive electrode in electrolysis cell are made up of carbon. Why do positive electrodes need to continually replaced? Okay, so what is being asked is basically the positive electrodes in electrolysis are made up of carbon. Okay, yeah, I got the question. So, during electrolysis of aluminum oxide, oxygen gas is formed at the positive electrode, okay, which is called anode. Because these electrodes are made up of carbon and the process occur at very high temperature, the oxygen react with carbon to form carbon dioxide. Okay, like carbon, oxygen, they combine and they make carbon dioxide. So this causes carbon anodes to, gradually burn away, which is why they must be replaced. Okay. So the option is this: carbon reacts with the oxygen um, produced. Okay, so yeah, you can see there is a measuring cylinder, and this is asking. It is showing the measuring cylinder during an electrolysis, and what is the volume of the gas in the measuring cylinder. Okay, so how do we measure this? Um, First, we scale orientation. The measuring cylinder is inverted, right? Why? For electrolysis, meaning the like zero mark is at the top. Okay. So the gas fill the space from the zero mark down to the liquid gas, and the numbers you can see are 2, 4, 6, 8, and 10. Then there are 10 small marking between each whole number, like between 2 and 4. You can see there are 10 marking, 1, 2, 3, like this. So basically, this small each, this means like each small line is representing how much the gap between 2 and 4 is. 4 minus 2 is 2, divided by how many small lines are there, 10. So if we divide, we will get zero point 0.2, right? zero point 0.2 centimeter cube per division. Now, how do we find this? We locate the liquid level. We can see this is between 2 and 4, right? Let me erase this. This is between 2 and 4, between 2 and 4. Then we count the marking from the 2 downwards. The liquid level sits exactly at the what line? This is fifth, right? Sixth and seventh. So this is seventh line. So basically, what you need to do, 2, because this difference is 2, plus 7 times 0 0.2. This is seventh line, right? So this is going to be 7 times zero point 0.2 is 1.4, and if you add this, this is 3.4. So this is the correct option. Okay. Hydrogen gas is produced instead of magnesium at the negative electrode. Why is hydrogen produced at the negative electrode? Because see, uh, hydrogen is, since magnesium is more reactive than hydrogen, so hydrogen ions are more easily reduced. Okay. So, like in reactivity series, if you see, magnesium is much, much more higher than hydrogen in reactivity. And during the electrolysis of aqueous solution, the least reactive positive ion is discharged at the cathode because hydrogen is less reactive. So that's why H2 is produced. So correct option is hydrogen is less reactive than magnesium. Okay, now we have a graph which shows the result for the volume of hydrogen collected. Okay, and which hypothesis explain the result in figure 7? Okay, so basically, on this graph you can see we have time and we have volume, right, on y-axis. These are representing current, and the which is explaining the result. Okay, if you read this, the volume of hydrogen collected depends on both current and time. This is the correct option. Why? As you can see here in this graph, for any single line like a fixed current, the volume of hydrogen is increasing as the time is increasing, right? They both are increasing, like this is time and this is volume, and the graph is going upward, so it is increasing, right? So that means they depend on both. And at any specific point in time, the volume, if you see the current, as the current is also changing, right? So that means it depends on both hydrogen collected and I mean, it depends on current and time, right? At different current we got different graphs, right? So this is the correct option. Let's see next question. Okay, so again we have the graph. We have to calculate change in volume. The formula for gradient is given. Gradient means slope, which tell us about the steepness of graph. So basically on x-axis we have time, same graph. This is because on x-axis we have time, so this is change in time if you take these 2 points, and this is change in volume because here we have volume on y-axis. Change in volume, gradient means y2 minus y1 over x2 minus x1. You have formula already. Y means y-axis. On y-axis you have volume. X means time. On x-axis you have time, right? Change in volume. The vertical arrow starts, if you see this graph, this is this value um, is okay. If you take any 2 point, determine the gradient. Okay, let's say you take this point. No, not this point because the graph is going there. Let me just erase this. Okay, so the change in volume is going to be, if you see this point is 4, and as this is 4.9, 4.8, so this point is representing 4.8, right? And this point is 1.9, right? Because this is 2 and this is 1.9, as you can see just below 2. So how do we find change in volume? Just do final minus initial. 4.8 minus 1.9, that's change in volume. So if we just subtract it, what we will get, 4.8 minus 1.9 is 2.9. Okay, so change in volume is 2.9. Now we have to find change in time. We have time here, change in time. Now you see this arrow, this is representing 5. So 5 minus this point is representing between 2 and 3, 2.5. So 5 minus 2.5 is 2.5. So this is 2.5. Now we have to calculate gradient. You can see the formula is change in volume, which is 2.9, divided by change in time, which is 2.5. So if we divide it, 2.9 over 2.5, we'll get 1.16, and that's the gradient. Okay. Um, yeah. Now let's see this question. So this question is about nanoparticles, and this is a nanoparticles made up of carbon atoms in figure 9. First question says, oh, sorry, what is the name of type of nanoparticle in this figure? Okay, so because it says it is made up of carbon, okay, so the correct one is, and if you look at the figure, this image is showing spherical molecule made up of carbon atoms, and this well, looks like a football, right? So this correct option is this. Okay, and then second one says nanoparticles are slippery. Which structural features of those nanoparticle make them slippery? So um, because they are spherical, they act like tiny ball bearing, allowing them to roll and slide past each other easily. Okay, they are spherical is correct option. Okay, if you have any question, you can text. I will reply, or in the comment, you can comment or text here. This is my number, 919205948909. Make sure you WhatsApp me. Okay. Okay, if you have any question, please ask. Bye bye.